Cool. So as you all heard, my name is Dalgleish, and I'm here all the way from Melbourne, Australia. I believe my 3-year-old daughter Eva is watching on the live stream. So hi Eva, I miss you. As I'm sure you're all aware, I'm a big fan of React for a number of reasons. There are lots of great reasons to love React, but the number one reason I got into it in the first place, and I remain a big fan, is the fact that React does universal rendering. We can render on both the client and the server. This is huge for me. So as front-end developers now, thanks to React and the world coming after it, we have a choice. We can either server render or client render, and this is a big decision for a lot of us. But I'm here today to talk to you about what I think is a really important but less well-known third option. And that's the idea of bringing universal rendering to the world of static sites. These two worlds can coexist, and I think the results are really interesting, as you'll see. But to put all of this in its proper context, I'm going to go back to the start of my journey on working in this space and tell you how I got to where I am today. I've spent the last 2 years of my life working at a company called Seek in Melbourne, Australia. And Seek is the leading job site there and in New Zealand as well. Basically, if you're in Australia and you're looking for a job, odds are you're looking on Seek. This is the project that I've been working on, and it's a complete rebuild of the core search experience using React, server-side rendering, to get all the best benefits of client and server rendering in one application. Now at Seek, we were already big fans of client-side rendering. A lot of our projects already had made the migration towards rendering purely on the client. And there are a number of really obvious benefits to this that I'm sure you're all familiar with. The number one, though, has to be that app-like user experience. The fact that once that application's booted up, you had a level of interactivity that we just did not get with our server-rendered applications before. And this was a big differentiator between us and our competitors, and I'm sure that's true of many of you. But the benefits carried over into the development world as well, of course, and this definitely helped it gain traction with us. The fact that we had a simplified architecture of a static site talking to APIs, which meant simplified deployments, and that also translated into simplified operations as well. Running these things was just so much easier than it was before. And for many of us, and it was definitely the case at Seek, this was the beginning of us breaking down these monoliths that we had, where we had front-end code, back-end code all tangled together in the one project. Now we had a really nice, clean separation. Static sites talking to APIs. It was like building a desktop app or a native application, but on the web, and it felt really, really great. Unfortunately, this approach had and continues to have a fatal flaw. And that's that first-time user experience of hitting a website that's rendered on the client. Odds are you'll see absolutely nothing for a second, and then you'll see a loading indicator, and finally you'll see some data. Really not a great experience for our users. Enter React, of course. So React helped change the landscape in this regard. Most notably because you could take an application and you could render that application to a string. This was huge and something that at Seek we really paid attention to. The number one thing that changed when we started working with it is suddenly we were talking about progressive enhancement again. It was something that we had stopped talking about once we moved towards single-page apps, suddenly relevant again. Search engine optimization was the entire reason we got on board in the first place, and the benefits there were immense, both in terms of targeting search engines, but also testing that you're targeting search engines correctly. But finally, and I think most importantly for me, a benefit that you continue to see day after day as a regular user is that first-time load experience. We heard Guillermo talk about this yesterday, and it's definitely true for us that that final level of polish in your application is that when a request hits your server, the user sees usable, readable content as soon as possible, not a blank screen, not a loading indicator. Now, of course, many weeks pass as we work on this new project, and the realities of working on a real project start to set in. Components are everywhere. That's what happens in a React application, and obviously we think that's a good thing. And in our case, the components were universal. They were designed to render on the server first, and eventually run on the client. And who knows how long that period of time is going to be. That was built into their design. So as a team, we all looked at each other and we said, well, we've got so many of these starting to build up, we should really start to think about open sourcing some of them. For me, the natural next step in this is thinking about how we demonstrate the universal nature of our components. And I wanted to put them up on GitHub pages. As we always do with our open source components that have a demo, let's put it up on GitHub pages where people can see it. But there was a slight problem with this approach, and that's the fact that GitHub pages is static. All you can do there is upload static files and serve them directly. There is no dynamic server component. Your node server rendering is not going to run in this environment. So I thought long and hard about this problem, not too long. What we came up with was the idea of rendering our components to HTML at build time without a dynamic server. And this is where Webpack for us continued to pay off. It's an incredibly powerful tool, as I'm sure you're all aware. Or more specifically, the Webpack plugin system gave us the power we needed to solve this problem. Because Webpack plugins, in this case most particularly, they have access to every generated asset. So every file that's coming out of your Webpack compilation, your plugins have access to that. But they also have the ability to create additional files. Many of the most common plugins do this. For example, the extract text plugin that generates CSS. That is reading your source code and generating extra CSS files as a result. That's the kind of power we needed in this case. And that led to the creation of a somewhat hacky but definitely workable solution called React-to-HTML Webpack plugin. And it would basically look like this. In your core bundle, typically you don't export anything unless you're building a library, but in this case, the idea is that you would export your React component. So here we've got a simple Hello World app component, and we're exporting that from our bundle that we're passing into Webpack. In our Webpack config, we can create a new instance of our React-to-HTML plugin saying that we want to create an index.html file. We want to use the component exported from component.js from that generated asset. And we also want to provide a template for the HTML that surrounds that HTML that came out of that component. So I'm sure for a crowd like this, you want to know what's going on under the hood here. How does this even work? Well, Webpack plugins are basically just classes, and they have an apply method on the prototype chain that accepts the compiler and is able to act on that. So in this case, we're hooking into the emit lifecycle event, which is when Webpack is just about to output files to the file system. Here you have access to the compilation, and that allows you to do things like this. You can have access to the assets in a couple of different ways, and once you've got a handle on that asset, you can call the .source method on that and get access to the raw source code of that generated asset. So now we have access to the compiled code that's coming out of Webpack. If it's run through Babel or anything like that, all of that's already done for you. You have access to the resulting code that you would typically then execute. What can we do with that? Well, the obvious answer might seem to be that we just simply eval it. We have a big string of code, let's eval it. But there's a bit of a problem with this approach, and that's the fact that eval doesn't understand node modules. Eval's been around quite a long time, much longer than node. This is going to trip us up if we try to do this. So what's the way forward here? Well, when I saw this problem, I actually learned about something that's been in Node for a long time and I had no idea, which is the VM module. This is built right in. And one of the things that's on the VM module is this script constructor. And this constructor is basically eval on steroids. Because what you can do is you can create a new instance of it, passing in the string of code, but most importantly on that last line, you can see that you can run the script in a context that you define. You pass in an object and say, this is the global context in which the script is running. So what that means is that you have the power to create a node-like environment for this string of code to run in. You can create a brand new global object and pass it in. You can create an exports and a module exports. You can even pass in your own require that acts the way you want it to work. So in this case, we're using a really great open source library called require-like, where we can pass in the name of the file, which is the root of the require call. And then again, in that last line, we can pass this context in when we execute the script. That's all a bit tricky and error-prone. Luckily, there's a great package on NPM called eval, which does all this for you. So that's what we use. So when you bring in this eval package, you can now evaluate the source code that's been generated by Webpack. And we now have a handle on whatever was exported from that module. So in our case, what's being exported is a React component. With that component, we can now pass it to React.createElement and get a handle on the React element, which we can then render to a string, resulting in the final HTML that we want to render to a file. So Webpack, of course, gives us the necessary hooks to then create a new asset and set that as the source code and write it to disk. But what we found, of course, is that this experiment only scratched the surface. Rendering only a single component just wasn't enough. What if we wanted to render multiple routes? It's very, very common for us, even on GitHub pages, to want to have multi-page websites, but acting as a single-page app and navigating between routes and showing what a real React application looks like. But if we're going to go in this direction, how do we decouple ourselves from React Router? If we created a React Router to HTML plugin, one of the earliest problems we would have faced is the fact that the React Router API kept changing. And we couldn't couple ourselves to any particular version. So we needed to avoid that. But if we're going to continue down this path, how do we decouple ourselves from React entirely? What's so specific about React in this problem? Because essentially, we're just trying to render an application to HTML. Really, what we're trying to do is generalize the API from this, where you export a React component, towards a more general solution where you export a render function, which has a much simpler contract of returning an HTML string, whether synchronously or asynchronously, depending on your use case. So here we've basically got the same behavior, but we have more control over it, because in that render function, we're the ones deciding to render a React app to a string, which means that already you can see that if you wanted to render to static markup, because it wasn't a single page app, you have the power to easily swap that out. That led to the creation of a much better plugin, which is Static Site Generator Webpack plugin. I'm sure a few of you have probably seen this before. The idea being that we should be able to compile a render function and execute it at build time. But most importantly, we want to do it with the full power of Webpack. Webpack gives you all the tools you need to build a really, really rich application. And what we wanted to do is bring that to the world of static sites. Now, this render function needs a bit more information passed into it to be useful. So the built-in property that gets passed to you is the path. In this case, we're not using it for anything yet, so let's do that. Let's flesh that out into a bit more of a realistic application. So now what we're going to do is we're going to pull in the server router from React Router. And now we've got this path, we can pass into it with the location prop. And you've basically got what you typically have on a node server running in your build step. If you want to add Redux to your application, it's the same kind of process. On every render, we're going to create a new instance of our store. We're going to pass that store to the provider component that wraps our server router, that wraps our app. If we want to fetch data, we can asynchronously do that. Here we're returning a promise from our render function. And only when we've finished resolving all the promises for fetching data will we then attempt to render that file to HTML. This fetch data function, of course, can be written however you want. So if you want to use a library like Redal, which is designed for solving this problem, you can do that. So here we're triggering the fetch lifecycle hook that we've defined on all of our route level components. The important thing to note here is that all universal libraries can now be used at build time. Any JavaScript library that you've seen or used that's designed to work in both a server and client environment can now be brought forward to the build time compilation step of your Webpack build. Because if you think about what the job of a node server rendering a React app is, it's all about converting URLs to HTML documents. That's really all it's doing for you. So we're bringing that server rendering workflow earlier into your build step instead. Now, if you hook this into your Webpack config, it looks something like this, similar to before, where we're creating a new instance of the plugin and we're telling it that we want to reference the render bundle that we've defined elsewhere in our config. But most importantly, in that last argument there, we're passing an array of paths that we want to render. So in this case, you can see that we're attempting to render a blog. It's a very common use case, of course. Now, your render function is going to be called with each and every one of those paths that you've passed in. But most importantly, an index.html file is going to be generated for each and every path, which makes for a nice, simple deployment to a lot of static site hosting where the index.html file is automatically resolved for a path. Now, it became apparent to us very quickly that we'd stumbled on a very important new pattern. An initial problem that we had early on as we were rebuilding the UI is that we had to port some of our new React code to our legacy platform, which still had some time left to hang around in production. We leveraged the really great open source auto-suggest component by Misha Moroshko, who was actually working for us at the time. And we needed to add it to the homepage of our classic site, highlighted there on the screen. And we'd built this to work across both of our projects. Now, the problem is that that classic site was not a Node server rendered app. It was a classic .NET app using very old technology. And so that meant that if we weren't careful, our form would instead look something like this, right? You would load the page up, everything .NET did would have been rendered, and everything React did would be waiting until the JavaScript loaded. And obviously, this was unacceptable for us. But how could we also avoid the complexity of server rendering? The last thing we wanted to do was introduce a much more complex Node server-based rendering architecture hooked into our legacy site. We didn't want to go there. So again, we thought some more about this problem. This one seemed actually a little bit more tricky to us. How are we going to solve this? And that's when a light bulb went off for me, because the form element is the same for every user. That's something we noticed very quickly. And that meant that we could statically render, and all the work that had been put into the static site generator plugin could be applied in this new use case. So what we did is we built the form as a standalone React component, and then we rendered that form with static site generator Webpack plugin, so static HTML, static JavaScript, static CSS. Then we uploaded those static assets to S3, and then in our classic application, we would dynamically inject those static assets into the site at runtime. Essentially what we'd done is we had got all the power of server-rendered React minus the server. All the work had been done at build time. Now this pattern continued to pay off for us in unexpected ways, because what began life as a tool for simple static demo sites evolved into the basis of our living style guide. This is something that we were just getting started with, and this is what it looks like. The style guide was all about showing off all the components and styles that are available to you working in this ecosystem, explaining the thinking behind them, and this is something that we thought was really, really important, that it also showed off how it worked in a real application. So what you had in that example there was that we had a complete static site demonstrating its usage. The static site consumed the style guide in a way that a standard Webpack-based app would consume it, which serves as a great way to iterate on the style guide as well. But it was built with a standard universal toolset. It was a static site built the way we build our server-rendered apps. It was built with React Router, Redal for data fetching, CSS modules, and the style guide, of course, consuming itself. So even for our simplest pages, we could now use the standard toolset across the board with the full power of Webpack to generate static sites as well as server-rendered applications. So even with wildly different constraints, where some applications didn't need to be server-rendered while others did, suddenly different projects didn't have to feel like different worlds from each other. Now, more weeks pass, of course, and our application is starting to become a reality, and we're shipping it to production. And as always happens, at some point, we had our first minor outage. Luckily, it wasn't for too long. We recovered okay, but our React servers were down while the APIs that we consumed were still up. Now, we thought about this problem some more, and what we realized is that the application could still theoretically work if it was client-side only. Our APIs were still up. The way we approach the solution to this is that with every build of our application, we would first server build, then client build, which is what we'd been doing up until that point. But we introduced a third step, which was a static fallback build. What we had now was a separate static deployment in case of emergency. If anything went wrong, and we would typically have served up an error page, let's serve up a pure static application instead. So while our server might, on a good day, return HTML like this, on a bad day, we just return that instead, with the full client-side bundle intact, ready to go, talking to the APIs that are still working. What we had here essentially was the world's most useful 503 error page. Much better than a sad face or some cute animation, we actually had a usable application that our users might not even notice anything had gone wrong. But the initial container doesn't have to be blank. That was just something we did for simplicity. There are a lot of other things you can do here. A really good example of this is a project called Colorable by Brent Jackson, which is up on GitHub. It's doing something that I'm pretty passionate about, which is validating the contrast ratio between foreground and background text, background colors, to make sure that your site is accessible. It tells you the rating that you get as well as the ratio, and it allows you to provide your own colors. Now, this is the pre-rendered view that comes out of GitHub Pages. It's actually using the technologies we're talking about. So this is what you see immediately when you hit that page. But if you've provided overridden colors, different values that you see at the bottom there, what's going to happen is when the client-side JavaScript kicks in, you're suddenly going to get this view, the client-rendered view. So some of the text might change, some of the colors might change, the form values will update, but you got to see something usable right off the bat. Essentially, this is your loading screen, much better than a blank page or a spinner. I'm sure you would agree. We've seen a similar approach coming out of the progressive web app community with service workers and application shell architectures. There's also a really good article about this on SitePoint with an approach called skeleton screens. And really all these things are about making sure that we render as much as possible, as early as possible, even ahead of time, to make sure we get usable content to the users as fast as possible. Even when we seemingly have nothing to render. The classic case of this is what Facebook have been doing with their newsfeed, where instead of showing you a blank page or showing you a loading indicator, even though they have to fetch some data, they're going to show you a silhouette of a newsfeed to help you get a sense of the content that you're about to see and improve that perceived performance. So when eventually the content loads, it feels much, much snappier. But if we go back and we look at that screenshot again, you'll see that there's nothing here that's unique to any particular user. You could serve this up as the initial render for everyone who visits this page. What we're doing here is, with a few simple tricks, we're drastically improving the perceived performance of our applications, bringing forward usable content as far as we can. What's great about the solution up to this point is that it had been built with a low-level, unopinionated plugin by design. And of course, this allows us to layer opinionated tooling on top, however we like. The best example of this I've seen in the open source community is a really fantastic project called Gatsby by Kyle Matthews. It's more of your traditional static site generator, and it looks something like this. The authoring experience is definitely something that those of us in the React community would find very familiar. On the left there, what you can see is editing Markdown like you would expect from a static site generator. But as you hit save, it's updating live on that right-hand side in the browser. So every time you hit save, you get the hot reloading, all the benefits that we strive for in our React applications on a static site, on a blog, or something similar to that. So this is built with Webpack, with React Router, and with Static Site Generator Webpack plugin. So again, it's all the power of a full server-rendered application that we typically expect, but it's generating a static site. It's a fluid client-side application where you can quickly navigate between routes. It's not moving between documents like you would typically do on a blog that we would expect. But the best part of it is that Gatsby users remain blissfully unaware of the fact that these are the technologies behind it. To them, it's just a simple static site generator generating HTML, and they don't have to deal with all the complexities behind this. Now, what started off as a niche problem, or what we thought was a niche problem, which is taking React components and rendering them so that we can put them on GitHub pages, this is not a problem that many of us would have to solve. Instead, what we found is that we'd stumbled on a widely applicable solution that continued to pay off for us in ways that we had never anticipated. Ultimately, the point that I want to make here is that universal rendering needn't only be relevant to a select few. There are a lot of us in this room that don't feel the need to server render our applications, but there's still plenty of room for us to fit universal rendering into our workflows in ways that I've showed you today. Because now, as front-end developers, we have a slightly different choice. We can server render, we can client render, or we can statically pre-render our applications to HTML. Or, I think most interestingly, we can create a unique combination of all three approaches to suit our particular use cases. At the end of the day, the reason I'm here to talk to you is because I want to change the way we think about static sites. For a lot of us, myself included, we think about dynamic server-rendered applications and static sites as being completely different things, sharing very little in the way that we think about them, the way that we build them, the user experiences that we expect from them. That does not have to be the case thanks to modern tooling, and hopefully it's something that you'll think very long and hard about trying out in your own applications. If you have any questions about this, I'd love to answer them, of course, but other than that, that's it for me. Thank you so much for listening. All right, well, that's hard for me to read. Okay. This seems like a lot of complexity for a benefit that maybe doesn't have many real-world use cases. I'm not sure if I agree with the premise that doesn't have many real-world use cases. I mean, one of the things I tried to present was that there was a surprisingly wide variety of real-world use cases that we could actually solve with this approach. And it is just scratching the surface of it. I agree that there is some complexity to it, but it shares complexity with Webpack, I would argue. If you're using Webpack, that's where the bulk of your complexity is, not in this final static rendering step. So I think if Webpack is too complex for you, that's a problem that many people are already trying to solve, and I think that's worth solving. Gatsby is a really good example of trying to solve this particular problem of rendering a static site. So again, if this is something that you think that it's too complex, I would really recommend looking into ways to simplify that and open sourcing it for people to share, like what we've seen with Gatsby. What do you think about Next.js server-side rendering approach? I think it's awesome. Next.js is really, really good, and I think for a lot of use cases where you really just want to follow the conventions and have something that does all the work for you, Next.js is a really good candidate for that. It's something that I really want to check out for myself. What about dynamic path definition and Webpack plugin configuration? Well, I mean, it's dynamic. It can be dynamic in the sense that it's JavaScript generating that array, because your Webpack config is a JavaScript file. At the end of the day, you have to resolve it to a static set of paths that you're going to render so that your build can actually finish. So I would say that you can have dynamic paths, but if you need to mix approaches, like if you actually need something dynamic in production, like I've said, there are ways in which you can mix a classic static site approach with a server-rendered approach and have the best of both worlds. So for example, if you have a server-rendered application, in our example we had a .NET application, but even if it was using Node and React on the server, you could potentially find opportunities to statically render things to HTML and read them from disk at runtime. So yeah, there's a few approaches that you could take to deal with this. How does this affect the size of the resulting bundles? It has no effect beyond what you would typically find with Webpack. So if you want to do bundle splitting, you can do that. It's completely on you. Really, again, all this is doing is just bringing forward that step of rendering to HTML to build time rather than at runtime on the server. How can we add transitions between pages? Yeah, so this is a problem. I feel like a lot of my answers are going to be very similar here. Transitions between pages is something that if you can do that on a server-rendered application, you can do it with a static site. Again, it's just bringing forward that rendering to HTML into your build step rather than at runtime. So you can use React Router in your static site, which I've done, and React Router has ways in which you can transition between pages. All of those methods that you would typically use, you can now bring to your static sites. So again, one of the big messages of this talk is that all that power that you typically associate with a server-rendered React app can come to your static site, including transitions between pages. Have you thought of incrementally rendering static sites, i.e. for large blog, you might want to avoid re-rendering pages which didn't change? No, this isn't something I've really thought about. I'm sure you can do it, but I haven't had to deal with this. How about code splitting and making the app a progressive web app? That's a great idea. Sure you can do it. I haven't done it. What about context? In eShop, user can add items into basket and HTML will change. If I want static generator, I can use Jekyll. All right, thanks for that. Yeah, again, I'm going to broken record a little bit, but anything you can do in a typical server-rendered app, you can do in your client-side app. One of the things that we do, that we've done at Seek, is that we realized that some of the content we actually didn't want to server render. We wanted to defer some of it to the client. Anything user specific, we deferred to the client. So there's API calls that happen on the server, and then we have API calls that only happen on the client, and we use Redial to manage those lifecycle hooks. So what you can do for an example like this is that you could statically render all the content that everyone sees, and something like a shopping cart that's unique to each user, you could not render that in your build step and defer that to the client. Do the other assets automatically injected to the HTML, CSS, JS like an HTML Webpack plugin? No, they're not automatically injected. That's on you to manage that. Yeah, you have full control over the HTML coming out. The Webpack stats for the build are passed into your render plugin, so you have access to all the information that you need. But there's definitely still room to make this a little easier. So if that's something you care about, please talk to me after this. Do you still have server-side rendering and these pages are used as fallback? Yeah, so we do want dynamic server-side rendering for SEO, for that initial performance. So if you're looking at it through a magnifying glass, potentially the losing out on the server-side rendering is a bit of a drop in the quality of the application from our point of view. But the way we see it is that the static site is a massive improvement over a standard error page if something went wrong. So that's why we sort of manage these two approaches at the same time. What do you think about the 15 kilo Webpack plugin? How does it compare to yours? Yeah, I wish I'd known about this plugin before I gave this talk because it pretty much invalidates everything I said. Not true. Are you aware of any technique that enables progressive server-side rendering using React? What? Yeah, render to string on a node server, unless I misunderstand the question. I think that's all the questions, so that's it for me. Thank you so much.